Okay, can everybody hear? Can you hear me okay there?
Yep, sounds perfect, and we can
Brilliant.
see your screen, so that's
So a bit
wonderful.
of an intro. We'll be sharing a pre-recorded video which was presented at the MRS Big Qual conference, which we thought the ICG membership may be interested in. And I should note that I appreciate it's a very sunny day with a rainy weekend ahead at the start of summer holiday. So I imagine this time slot is not priority one for most working parents. I've children myself, but if you do watch this recording and you want to get in touch, please feel free to at any time. The ICG format is great because it allows us to give a little bit more background. And firstly, I'd like to say it's been brilliant to be a part of this project. For us, it shows how smaller businesses and independents can collaborate, sometimes across borders, to make an impact. We're working with Red Centre Software. They're based in Australia, and they've been contributing positively to our sector from a tech perspective for decades, and they're really ramping that up right now. And it's that kind of attitude which in part inspired us to set up Bayes Price. Nikki and I went independent so that we can have the freedom to share knowledge and sing the praises of our sector in any way we want to, whether that's through the ICG or ASC, TSAPI or anything else. And I personally truly mean that, by the way. I love the way that MR can add an element of democracy to higher level decision making. I think that's very important for any society. So we're analysing an epic database here from Twitter. It sits outside of traditional market research. It's live. It's on a topic that's having a huge impact on humanity. So if we can use MR technique to make even a small contribution to that overall knowledge base, then we've done something meaningful from our perspective. And much of that sentiment kind of define the structure of the video we're about to play. We try and break down some of the techie jargon. We add references throughout to show that anyone with some learning or potentially some collaboration can access these kind of unstructured text or non-MR resources and techniques. You don't have to avoid them. You can apply your very valuable skill sets to them. On the topic of collaboration, I'd like to say now that we'd love it if an ICG qual expert was interested in getting involved in the project by helping us refine the off-the-peg Syuzhet and NRC Lookup dictionaries. They're all explained in the video. We want them to better suit the context of COVID. We could use that work to rerun the whole analysis and visualize. And from a return on investment perspective, it might enable that qual expert to recycle those techniques for other sectors. I'm not sure, but we'd love to get involved. Anyway, I hope you enjoy the vid. It comes with some sound effects. And if you can stick around for the live Q&A afterwards, brilliant. I'm going to now switch my video off like that and point my microphone at the speakers. Share my screen. Screen share, that one there. And play the video. Hope you enjoy. Hello everyone. Today I'm sharing knowledge on a collaboration project between Bayes Price, we're an MR support company based in England, and Red Centre Software, a cutting-edge MR tech provider based in Australia. It's a three-part presentation. Part one will discuss the tech aspects of gathering Twitter data, SQL storage, and many of the benefits of flowing that epic database into a market researching environment. Next, we'll unpick the techniques used to analyse a vast database of unstructured text. And these techniques are not limited to Twitter, they can be applied to any text data. And finally, we'll bring things to life with some interpretation, the analysis and visualization of what is possibly the loudest global online conversation ever recorded, the COVID pandemic. Let's do it. We connect to the Twitter database for free. It's via their API and information on that is available here. To do this, we wrote a program in Visual Studio, which is a platform Microsoft offer for free, and you can find that here. In this program, we connect to the Twitter database using our user credentials, set parameters such as the number of tweets to gather in each run, the language, the search terms, the hashtags, and the schedule. Ours is set to run every 5 minutes, collecting 200 tweets every time. In the next section, we create several variables and the insert query writes that data out to a SQL database, which is free too. Again, more information available here. We've been gathering COVID tweets since the World Health Organization declared a global emergency in January 2020. They're all stored on a single domestic level computer hard drive. Pausing there, it is true we could sign up to a platform which offers this kind of social media data gathering, but we often found ourselves restricted by third-party business models in terms of budget, pricing scales, function, and importantly, access to raw data. A lot of our credibility as researchers is based on full transparency. We need to be able to follow every number back to the individual responses, which is not always possible in third-party platforms. Also, social media platforms rarely analyse anything other than social media, whereas the techniques we're sharing today can be applied to any text data. So we've gathered millions of rows of unstructured text data. How on earth are we going to make sense of that? I'll go into detail on how we apply the Syuzhet Sentiment Scores and the NRC Emotion Lexicon, how we monitor growth of conversational subtopics, how we use machine learning models to tag emotional categories. I'll share how and why we flow the data into our standard market researching tools, the environments where we're already comfortable, so that we can apply our experience to quickly analyse and produce those bespoke visual outputs that our clients love, PowerPoint reports, interactive dashboards. You've got all that to look forward to, but at the moment, let's talk databases. It's important to spend a little time discussing relational databases, RDBs, and how they can differ in structure from market research survey databases. We often work with RDBs rendered via SQL with one type of information in each column. In many cases, these are thin and long with records running into the billions. Most of the world's data is stored in RDBs, and a supreme advantage is connectivity. There are loads of free tools and languages available which make it easy to pick up data from a variety of sources and create new tables, datasets, calculations, anything you want. Now, market researching databases can look slightly different, and there's a very good reason for this. Imagine we're asking, which of these 20 statements do you think apply to our brand? In RDB world, the answers require 20 columns, one for each statement. Ask that of 10 brands, and suddenly we've got 200 columns of data for a single question set. The number of columns the system has to deal with impacts on processing time and our ability to work with that data, especially when it comes to creating aggregated data tables, which are the fundamental building block of nearly all visualization. Processing problems can lead to time management issues, dodgy data, browsers crashing, all that kind of thing. It's a nightmare. We, as an industry, have been refining our approach to this challenge for decades, and we deal with it incredibly well. Instead of 20 columns for each brand, we create one multiple response variable. Instead of 200 columns, we only need 10. Some platforms can reduce this down even further using compound increment variables. Therefore, if we can convert RDB into an MR structure, we can enjoy loads of advantages. Firstly, if you've built RDB-based tabulation scripts in a standard open source software, it's possible you're going to have to start all over again if the data structure changes, and that is a major headache. If we use MR tools, however, we can handle it. We can add new brands, we can combine statements, drop options off, all on import. For many, MR tools are much easier to use. As hands-on consultants, we're right at home with a drag-and-drop interaction. We can use data tables as our base tool for investigation, quickly editing banners, side axes and filter definitions. Updating tables is just a click away. You don't need to be a whiz with scripts in order to make this happen. The structure also means we MR professionals can tabulate data incredibly quickly. While I was talking to you then, we just processed 17.8 million data rows. And once processed, we can update the actual table's structure and format to suit any particular requirements instantly. We also enjoy live connections to Excel, PowerPoint charts, Tableau files, the list goes on. Many of us just take this for granted in market research, but we should be aware that solving these problems can be of immense value, perhaps even improving our fit within the wider business intelligence and tech communities. From our perspective, everyone can now have the best of both worlds, RDB connectivity and storage, with the power, processing and ease of use of the MR toolkit. And it doesn't have to stop at Twitter either, we can apply what we're sharing to anything. Okay, enough about databases. On to the analysis. So back to the question of how we're going to analyse all this data. We could spend millions of pounds on an army of humans to code 60,000 tweets every day into topic, category, sentiment and emotion. But we don't have that kind of budget. Logistically, it's tricky to secure and manage that number of coding professionals. And we'd have an issue with consistency when so many humans are trying to interpret the same dataset in precisely the same way. Therefore, our first port of call is to use machines and automated processing to provide us with what we call a forest eye view. To stretch the analogy, we can provide an overview of the content and general health of the forest very efficiently using automated processing. What we as researchers cannot do is say these same processes will offer a precise and thorough understanding of every tree, bug and shrub in the wood. For that level of detail, we need to isolate an area of interest, zoom in and apply a more nuanced approach. And, similar to ecological studies, those two approaches complement each other really well. Our first step is to pre-process the text. There are some standard transformations like removing stop words, normalizing and tokenizing. We're not going to spend time discussing them in this recording. A transformation that is worth spending some time on is held within the ML program we're applying called Featureize. It's available via Microsoft here. Part of that program transforms every text character into a numeric value. So it doesn't matter what the characters are, they're all converted into UTF-16 format, which includes emojis and every language. Therefore, the ML solution doesn't actually read English, it reads UTF-16 character bytes and assigns a single yes-no value to the text, in this case to denote the presence of panic and/or denial. It does require training data, so it learns from a sample of what a human has already coded, in whatever language that may be. What happens is that training data is used to adjust the weights within the program's default regression equation, and then it rolls that refined solution out across the full database. Yeah, it is tempting to view ML models as the silver bullet for automated text sentiment analysis. A machine learns from a real human's interpretations and then assigns tags at light speed. However, there are some hazards we should always mention and keep in mind. ML models often require a large training dataset, which means a financial and time expense of human coders, and it also means they're less useful for smaller projects like your standard MR survey. We need to be aware that mistakes are learnt too. If the training data is coded inconsistently or incorrectly, those mistakes will be rolled out, and who's going to validate all that data? They can be domain specific, so if it's trained on FMCG, it's not going to be much good for political polling, and nuances can be lost, like the difference between the word service and services, which is a real problem for sectors like utilities or insurance. Buy-in can also be an issue. It's very hard to explain regression equations or neural net determinations, or even understand them yourself, which kind of makes the final point that a lot of these ML solutions are black boxes. It's very difficult to achieve that full level of transparency at the respondent level, which our profession demands. Another approach to text sentiment analysis is to apply dictionary lookup systems, and we're using two. The Syuzhet Sentiment Score, which is a system used a lot in humanities and academia. In essence, we have a dictionary of words that are pre-coded on the positive to negative scale. As an example, Syuzhet scores good as +1, love as +2, and bad as -1, and we simply assign the scores to the words in a tweet and calculate the total. So love is good would be +3. This provides a single tweet level measure on a negative to positive scale. In terms of creds, it's developed by the Nebraska Literary Lab under the direction of Matthew Jockers. The R package is available here. There are lots of papers and lectures on the topic, and it's evolving, it's transparent, it represents a vast amount of human effort. And in other studies, we've found that translating the dictionary, even by something as accessible as Google Translate, produces analytically robust results. So there's a return on investment there. The other dictionary lookup we're applying is the NRC Lexicon. This is a multiple response categorization system. Each word in the NRC dictionary is assigned to one or more of these 10 emotions, and again, our tweet level texts are coded as per the dictionary lookup. This is derived from the work of the National Research Council of Canada, who crowdsourced 100 coders to read 30 modern American novels each. The NRC assignment is the average of the natural language deployment of the words in that context, so there's a great deal of work that's gone into this. Like any approach, dictionary lookup systems have their pros and their cons. On the plus side, they work on a single case. There's no training required or minimum database size. It's transparent processing and completely replicable. You could reproduce this with a pen and paper. It's fairly easy to explain, which is important when we're trying to secure buy-in from those who are outside of our field of expertise. The dictionaries can be edited. They can be extended to suit your particular interpretation, project or category. And the NRC dictionary is already available in over 40 languages. Now we do get false positives. Without tweaking the dictionary, there's no account of a context. For example, not good scores the same as is good. That said, research suggests that false positives and false negatives cancel each other out. So in a large data set, it averages as a genuine signal. And, as I've said, you can edit the dictionaries to suit. They're just a text reference file. And there is a slight irony that their transparency leaves these lookup systems vulnerable to critique, which is precisely why we should consider using them. Let's get under the hood, let's see what's going on, and we can easily tweak the assignments to better fit our market category or particular interest. So now we have an understanding of the sentiment within a tweet, and we also want to understand the content. What are people talking about? For that, we simply ran some frequency tables based on popular words and combined that with our own subjective interpretation and understanding of the context. We picked out key topics of interest and tagged those words within the dataset. It's fairly simple. It's worth stating that should a new word of interest emerge, because we own the dataset, we can retag the whole thing in roughly 4 minutes. We did that recently with Delta, for example. Alrighty, on to part 3, findings. Let's start by tracking overall sentiment via the Syuzhet scores. We've connected our data table in Red Centre's Ruby platform directly to the background data in the PowerPoint chart. Firstly, that means we can define our own time periods. In this chart, we're showing monthly data points. It also means that these charts update as our database does. So, in effect, we've forged a direct connection between the live Twitter database and an offline bespoke PowerPoint report. Just to repeat that, we've connected Twitter to PowerPoint. Here we're showing our sentiment categories, strong negative in the dark red up to strong positive in the dark green. And this is PowerPoint, so we're completely free to overlay an average to give us that forest eye view of trends within the dataset. We can see sentiment moving towards the more positive and then slipping back over time. Let's bring in those top topics that we tagged. Again, a direct connection to the Ruby platform using the same monthly time period, and we can get a good understanding of how the composition of the conversation has shifted over time. We've included vaccine, pandemic, deaths, Pfizer, lockdown, Trump and AstraZeneca. Visualizing shows Trump being prevalent around October last year and discussions around vaccines lifting up from December onwards. As discussed, we back-coded the entire database to include Delta and its recent impact is clear. And we're working in MR tools connected to PowerPoint, so we're free to customize the time period, isolate the latest 8 weeks and present that rise in more detail. Now what this doesn't tell us is levels of sentiment within each topic of conversation. But MR Tools makes creating this table very easy. Visualizing shows stronger positive sentiment among vaccine conversations, slipping into the negative with discussions around lockdown, and Donald Trump being classed as a strong negative position between death, Delta, and the pandemic itself. Let's not forget, we can filter our data to access individual tweets and bring particular areas of analysis to life. Moving into our NRC categories, remember that is a dictionary lookup system which tags each tweet with up to 10 emotions. Here's the frequency table across the total sample showing distribution of tagging across trust, fear, anticipation, sadness, anger, joy, surprise and disgust. If we merge these emotional categories with our subtopics, we can create an emotional index within conversation. Among pandemic-based tweets we see fear and sadness over-indexing, whereas emotions of trust and anticipation are far more frequent in tweets about vaccines. And we're market researchers. We demand flexibility when it comes to aggregated data tables, and in an instant, we can add Syuzhet scores and visualize a triple layer analysis combining emotion within topic category and average sentiment of each. Therefore, in a single visual, we can present anticipation and trust in vaccine tweets relating to a more positive sentiment, scaling down to pandemic tweets where fear and sadness connect to a more negative sentiment. In our MR tool, we can go even further. Again, never breaking that chain, we run our perceptual mapping and pull those coordinates into a customized scatter plot to show relationship groups among topics and emotions. We have one group relating to vaccines, trust and anticipation, Trump and surprise in another, fear, sadness and the pandemic in another, and an intriguing overlap in the center, potentially due to different interests and opinions competing for space in these areas. There are many ways to interpret and represent this analysis, and that is very much the point here. We're now firmly in MR subjective analysis land, which is part of our value offer to the world. Moving into machine learning tags, we visualize this over time. Panic tags generally decreasing over time, but notice with a single click, the chart updates with the latest data. Displaying weekly time points might inspire us to zoom in and apply that detailed approach to investigate some of the peaks, or whether this rise in panic tags is in any way correlated to the rise in delta mentions. We're going to stop at the forest eye view though, as we only have a few minutes left to present. MR tools give us power in so many ways. We can take our aggregated data tables, where all the heavy calculations have already been done, and reshape them to best suit visualization software, which can fall over if we ask them to run heavy calculations via a browser. By reshape, I mean converting into a single column to define the KPI and a single column to define the percent or raw count. That long, thin shape which works so well in data viz platforms like Tableau. Here is our visualization on Tableau Public, which everyone can access. It enables us to communicate key information to the world for free. Plotting Syuzhet sentiment over weekly time points presents that lift to the positive earlier in the year, And the beauty of Tableau is you can easily fuse multiple data sources and add context to your findings. Below, we've connected to the Our World in Data vaccine stats, which shows our lift in Syuzhet sentiment corresponding with global vaccinations rising above global cases in early Feb. The interactivity of Tableau is another great benefit. The user can follow their own interest, perhaps looking at tweet topics on a weekly level to see the peak in vaccine discussions corresponding to the FDA approving the first US vaccine. You can also highlight the trend of Delta mentions, which rises as overall sentiment falls, a trend beginning just after the World Health Organization calls the Delta variant a global concern. We can set things up so the user can click to zoom on the latest 7 days, a more exact view of how things have been tagged on a single day, whether they are emotions, topics or overall sentiment, and further, Tableau enables users to follow a unique line of inquiry via a free text search within the latest tweets. Just type whatever comes to mind into the free text search box and click return. And we can also drill down further by selecting the date filter, in this case 1st of July. As I say, this viz is public and free for all to access. Please do have a look around and share. We're hoping it might contribute some value to the situation that we're all in. So let's recap on the data flow and key software. We start with the Twitter database, pulling in 200 hashtag COVID tweets every 5 minutes via their free API, using Visual Studio to define the search parameters and to action. Tweets are tagged in this environment and then written as variables to SQL database. We can then reshape that data, again using Visual Studio, and import new cases into Red Center's MR technology. We use the Ruby tabulation engine and GUI to generate our aggregated data tables, then connect those directly to outputs such as PPTX charts, Excel tables, and Tableau-ready data files. And by the way, this process is going to be made a lot easier very soon with Red Center Tech connecting direct to any source. No need for Visual Basic. And beyond the nuts and bolts of this process, it's clear that the wider world of data users do have an analysis and processing challenge to which our industry's technology and talent is a perfect fit. As we've shown, it's possible to enable market researchers to apply their tools and their skill sets to a much bigger realm of business intelligence. If we can do that, then the future is bright for our profession, and we have a lot of value to offer the world, if only we can connect and collaborate. And the value of connectivity is another reason why it's in everyone's interest to support, endorse, and contribute towards movements like TSSAPI, the global initiative to create an API standard for transferring survey data. The easier we can make it to transfer data around our industry and to plug into other knowledge-based sectors, the faster we can connect our solutions together, which will mean better results for everybody now and a boost for future innovation. Thank you for your time today. Please do support TSSAPI. Hello.
Hi Matt, that was fascinating. I have to admit I did get lost a little bit along the way, but yeah, very interesting presentation. Thank you for that.
Did you enjoy section 3 at all?
Section 3.
The section 3 where the findings were told about the insights that the Twitter database has given us.
Yeah, no, but I think probably I'm going to have to review it to digest it all. Certainly a lot of fascinating stuff in there. Right, so does anybody have any questions out there? Yeah, we have one comment. Wow, amazing! But I think my brain exploded somewhere in section 1. Yes, I think probably a few of us are reeling from it. So yeah, fascinating stuff.
Yeah, I suppose I hope that as a recording, we're just trying to put references in there. I appreciate it was a lot at the same time. It took us a long time to sort of condense it down. But if we have the recording there, people can skip through it at their leisure. And if they find a little piece of interest, feel free to get in contact and we can discuss it further.
Fantastic. So I do have a couple of questions for you, just to get the ball rolling. So first of all, how did you get involved in this? And did you have a client who triggered the idea of doing some work on COVID, hashtag COVID, right from the start? How did it all start?
Yeah, we've been collaborating with Red Center Software for several years. On lots of different types of projects, and so when and they've always had an interest in connecting to data sources outside of traditional market research, because the engines and the tools, as I've said many times in the video, that the market researching sector uses are phenomenal in comparison to a lot of the general data processing stuff. So they were always interested in that. And and we were running a few Twitter searches and gathering a few pieces of Twitter data, one on the UK election. And then when COVID happened, they instantly switched the Twitter data gathering to COVID as soon as it was declared a global outbreak. So that kind of historical data gathering is fairly unique outside of your major pay-for platforms. And that's another key thing, is that we're trying to do this for as cheaply, if not free, as possible, to show a proof of concept that anybody, there's no paywall, there's no barrier to this. The Twitter API is free. In fact, when you pay for the Twitter API, sorry to go off on one, when you pay for one, you get options like you can filter on geography. I should caution there that a lot of people have noticed that that particular geotagging is not overly reliable. So a lot of people get tagged as coming from the US when in reality they're positioned in the UK. Clients have noticed that when it comes from, they only released a product in the UK, but most of the people talking about it are in the US. So it doesn't add up. So just beware there if you're paying for something. So when this happened, we were talking about it for a long time and gathering the database and refining our approach and applying different methodologies. And then, we then visualize that in Tableau Public. You know what it's like, one thing leads to another. And before you know where you are, you've got this whole project, which we're now trying to share as knowledge and promote the sector and share via videos like this. And so thanks for giving us the opportunity to share it.
Yeah, well done, well done. We have a few questions coming through. Yeah, somebody's just said that they're going to be watching the video again. Yes, like me, I think probably you need to watch it at least twice to be able to fully understand. Thank you, Matt. It was fascinating to see Trump score the most positive mentions, or did they get it wrong? Is that, that right?
Trump, yeah, but that was very negative. Trump in general was classed as talking about things in a negative way and in ways that surprised people, particularly while still in office. And then he dropped off, the conversation of Trump dropped off Twitter, especially when he got removed from the platform. But no, Trump was positioned extremely negative, just a little bit more positive than the pandemic, but a little bit more negative than the concept of death. So yeah, fairly negative for Trump there.
Okay. How do you cope with non-English language tweets?
Yeah, we just selected English only, which is the de facto language for, I think it's around 38, 40 countries, including North America, US, Canada, India, of course, and a lot of the countries on that, Australia, New Zealand. So this is very much an English-speaking analysis. If we were to cope with non-English tweets, if we were to have non-English tweets, then we could still use the machine learning tagging, because as said in the video there, it converts everything to an integer. So so the UTF character bytes, so that even if you put an emoji in, there's still a character byte for that, so that you can run your tag in a machine learning, because it's not reading English, it's just reading the UTF. So that's one thing, and it uses machine learning as well. So if you're teaching the machine on French or Spanish or Mandarin, then you can it will learn from that. It's whatever the human has done. As we said, the lookup dictionaries in other studies we've used work remarkably well if you translate, say, from German to English using something like Google Translate. So that's amazing, particularly when the languages have a root, a similar root, like European root. So that's how we deal with that.
With languages, okay, that's great. If anybody wants to come on webcam and off mute and ask their own questions, then please feel free to do so. How close are we as an MR industry to this sort of collaboration or synthesizing with the wider data world? How niche or not is this? Well,
so how close are we as an industry collaborating with the wider data world? Not close enough, in my opinion. We are, as an industry, we used to be fairly prominent when it comes to working with data, but as we know, client-side insights teams are growing, and not everybody is going through the market research channels. Probably most people are not. They're studying mathematics, data science, statistics, and using open source software. So we really need to champion some of the techniques and promote some of the techniques and tools and regulations and standards that the MRS and the Market Research Society in general has been developing for decades. I think it'd be an absolute tragedy if we get leapfrogged or sidelined but by newer techniques. I think we've all got a lot to learn from each other. There's so much, there's a little bit politics involved in that, I think, from historically, but the practical nature is we have a lot to offer. Now, one of the biggest barriers, I think, is connectivity. In the rest of the world, everybody just flows knowledge and data around. They've all got their standards for flowing data between different things. Whereas in MR, we're still mostly moving things around in file formats. We don't have that. You know, like emails have a certain standard for transferring email. You don't have to download a file and then upload it into Outlook and then download your file and send it to somebody else to upload it somewhere else. We need that standard, and that is what the TSSAPI is all about, connecting all of this brilliant innovation and wonderful platforms that we have to each other, but also to the rest of the world. And I think, and if we can do that, there's a great opportunity at the moment, and there's a great bit of enthusiasm about it. If we don't do that, we do risk being overlooked, because who's going to innovate and plug into a sector where they have to write a new API for every single bit of software when they could just plug into a whole industry somewhere else? They're going to ignore us.
Okay, so can you give some examples of where you think in market research this would be a useful approach to offer to a client?
Yeah.
And what sort of additional budget would you think you would need to add in to cover the cost of doing an exercise like this?
Well, an exercise like this, it's very difficult to put a figure. We're doing it for fairly free at the moment. It doesn't cost an awful lot beyond people doing it for you. So if you enable other people to do it, then that's something different. Now, this is focusing on social media, and I should say that social media and Twitter itself, we're not trying to say, as everyone says, Twitter is not a fair reflection of society as a whole. We're definitely transparent about that, but there isn't a huge amount of noise out there hosted on the Twitter database. So this is a way of using that. Now, some of the NRC and Syuzhet lookup dictionaries you can do on a single case. So if you only got 10 cases, you can still use it on that. So anything at all, but other applications would be, let's say you've got a CRM system where you have lots of emails coming in and you want to highlight different things, or you want to track sentiment or see emotions. You can apply that. You can apply our techniques to that kind of system if you want to. But really, it's beyond having all the ideas of application. What we're trying to do is share the technique so other people might then connect the dots. You know, it's all about collaborating. And I've got to emphasize, we love it if a qual person with expertise could take the lookup dictionaries, which is basically a list of words in the English language that has been assigned either an emotion or a sentiment score, positive and negative, and review that within their context of COVID, and maybe refine the scores or reallocate the emotions based on what they think the context of COVID deserves. I think that'd be a really useful exercise, and we'd love to incorporate that analysis into the visualization where you could drop down and see and promote that company as a partner. That'd be brilliant.
Okay, so there's an offer out there. Let's hope lots of people rewatch the video afterwards and you get some contacts. So otherwise, Phil, I think we've run out of questions. So just presumably, if anybody's got any further questions, they can contact you, can they?
Absolutely. Yeah, email on the website via the ICG base price or LinkedIn. Find me on LinkedIn. Happy to chat.
Okay. That's fantastic. Well, thanks very much indeed. That really was fascinating. As I say, I would definitely have to go back and watch it again to fully understand it, but certainly it's something that we probably need to be looking at and thinking about going forwards. Thanks very much for your time, Matthew. That was really very interesting. Thanks to everybody for logging in and for watching. I hope you found it interesting too. And we look forward to seeing everybody again at our next webinar. Bye, everyone.
Bye.